Hello everyone. Now in this session we will know about the concept about our recovery methods, and in that we know about the shadow paging means what? That a recovery methods is simply a shadow paging. Then what exact the database management system need a recovery, right? If the system crashes before commit, we need to recover the data, or maybe we need to go with the previous state, then we need to recover the particular situation to execute or to maintain the database consistent. That one is simply the use. Now the shadow paging is a recovery method. Then what exact the use of shadow paging? That one is simply we already know the concurrency control, which one is done with this type of types like locking method, or it may be a timestamping methods. With the help of this, we try to maintain our database consistent. Then again, if the particular failure occurs in between this process, then we need to again need a recovery method, and that one is simply a transaction management. Transaction management have a two concept. That one is a concurrency control and recovery method, and then we can say that our database is maintaining properly, or it may be in a consistent state. Now the recovery method, it's a controlling process. If at the time of controlling, if the failure occurs, then we need to recover it, and then it's done with the recovery method. Now the shadow paging concept is, we will go with the directly concept. That one is recovery method is shadow paging transaction. If the transaction runs, it creates a two pages or the two table. That one is current page table and the shadow page table. Then what exact the table page concept is? Under the shadow paging, definitely a database run with the concept of simply the when we run this shadow paging is a consideration about the database. The database is available with the particular scenario. That one is simply the considered database have divided into the disk space into the pages, right? That is the consideration. Now the particular, we can say that this one is CPT, that is current page table, and this one is shadow page table. Then what exact the concept of SPT and CPT? Current page table means under the shadow paging, database is in a page format, right? When we apply some transaction on a particular database or a particular memory location, and that one is comes under this location, then we first to copy the current state of the particular page into the CPT current. It's under the current page table and also the shadow page table. That one is simply the initial consideration. This one is initial consideration. Now transaction is a current page table and the shadow page table concept. Now initially both are same. When we read write, it update on a current page table, means when any transaction start the execution, it update the current page table, not a shadow page table. That is the process. Now the current page table on a main memory and the shadow page table on a disk. Current page table on a main memory, this one is in a volatile memory, in a main memory, and is on a disk, right? We can say that this one is also on a disk. It's again the main disk memory. This one is also a disk memory. It's a main memory. Now when the particular transaction occurred, the particular this situation of the page, consider this one is a page 1, copy the situation of page 1 in the CPT table. That one is in a current page table. Initially, before starting the transaction, consider T1 is started now. Then it copy the means a page 1 on the CPT. Now this page CPT page 1 and the SPT page 1 situation is the same when the transaction initialized. Now the particular when any change occurred, it's only apply on this CPT, like read, write. It's one type of a log, we can say that, but not totally we can say that it's a log. It's maintaining the version of whatever the action done under the transaction. Now when the particular commit is occurred, this is updated into the shadow page table, right? Why it is called shadow page? Because of it's the same replica of the system. Then if the particular transaction update the database or execute the operations, it's run under the main memory, volatile memory. After the commit, it update under the shadow page table, and then it update under the particular page, or we can say that under the database. The frequency to access the particular disk is less under the shadow paging. As compared to the timestamping protocol, the accessing of the log is more, right? So again, a log is again on a disk, right? Every time any update occurs, we update the log under the timestamping protocol. Then accessing of the main memory to disk, we can say that RAM accessing the main memory under the timestamping protocol is large, right? Definitely it's will slow down the process. But under the shadow paging, the accessing between the, we can say that here simple, RAM to disk access under the lock based protocol is more, and under the shadow paging it's less, because of the everything is updated on the CPT, which one is available on the volatile memory. CPT means what? Current page table. And after the commit, it update the shadow page table, right? Which is on the disk. When recover, it is on a disk. Then after some transaction, it reflect in a CPT. After commit, it copy into the any modification of a transaction, it reflect in a CPT in a current page table. After the commit, it copy it into the shadow page table, which one is available on a disk. Now log based need more use of a disk, but in a shadow need is a less disk space. That is the difference. When the system perform another transaction, then it copy the SPT in a main memory. Means if any transaction executes something new things on a particular page, then it copy the shadow page table copy into the current page table, and then whatever the transaction done the changes, it firstly done on a CPT on a main memory, and after commit it copy into the SPT, and then it automatically update the database after the commit and or the when the SPT is updated. Now when the system performed another transaction, it's doing this process. Now log record overhead reduce. Here is a simple example I already explained you under the log method, or maybe under the log based system. Log maintenance is again overhead which is reduced under the shadow paging. Then fast recover. How it's recover fast? For example, if the transaction updated something and the modification done under the CPT, right, and the particular transaction crash or fail, then this CPT is again the delete all the records, because of that one is under the main memory or volatile memory. But SPT contains a previous state of the particular database. That's why it's recover from this SPT, and which one is available on a main disk. That's why that is the fast recovery as compared to the log based. There is no need to do the undo or redo, because of whatever the action done by the transaction, it's again the After the failure, it's removed from the CPT, and it's again copy the shadow paging table situation into the current page table, and it's again start the execution. That's why there is no need to undo or redo under the shadow paging. That is simply the difference between the log based and the shadow paging. And this is the one type of a recovery method, we can say that. Now the advantage: no overhead for writing a log records, no need to maintain the log process, no undo, no redo algorithm, recovery is faster. Disadvantage: data gets fragmented or scattered. Like we create pages, then the data get fragmented and scattered. After every transaction completion, database page contain old version of modified data need to be a garbage collected. That one is particular shadow paging, or it may be it contains some garbage information. Hard to extend the algorithm to allow transaction to run concurrently. It's with the help of this recovery method, it's again extend this with the transaction to run the concurrently. That is some disadvantage. And it's a situation if the system fails, if system crashes during the execution of a transaction but before commit operation. With this, it sufficient only to free the modified database page and discard the current page table. If the system fails, it discard the current page table. Before execution of transaction, state of database gets recovered by reinstalling the shadow page. Then again that transaction is reinstalling, it copy the situation state from the shadow page, and it's again doing the particular transaction. If the crash of system occurred after the last write operation, means after coming, then it do not affect propagation of changes that are made by a transaction. The changes are preserved, and there is no need to perform the redo operation. That changes comes under the shadow paging. That's why it's again reinstalling that changes with the current page table, and then again it start the operation. That's why there is no need to means a redo process after the commit. That is simply the situation under the shadow paging. Thank you.